All right, in college algebra, we're looking at complex numbers in lesson 1.3. Complex numbers. All right, let's do a little background stuff. First of all, let's look at this right here, the square root of 25. What is the square root of 25? Well, what this means is what number times itself is 25? Well, this could be 5, or it could be negative 5. The square root of 25 could be 5 or negative 5, because 5 times 5 is 25, but negative 5 times negative 5 is 25. So that's what the square root means. What number times itself equals that number? All right, well, what about this? The square root of negative 4. What's the square root of negative 4? What number times itself is negative 4? Well, it can't be 2, because 2 times 2 is positive 4. And it can't be negative 2, because negative 2 times negative 2 is positive 4. So it can't be either one of these. What number times itself is negative 4? Well, there's no such number. So this is what we call imaginary. This is an imaginary number. An imaginary number, we'll do the square root of 1. This is I. This is what we consider I. We have this square root of a negative number that we can't, there's no such number that works. There's no such number times itself that equals negative 1. Usually what we do is, this negative, we'll just send it out, and that makes us have an I times the square root of 1. So this negative will come out and make an I. And then the square root of 1 is 1. So this is just I, like I said here. But suppose I have one like this. The square root of negative 9. Okay, the square root of negative 9. Well, since I have a negative in there, that means this is going to be imaginary, because there's no such number that multiplies by itself and gets negative 9. So the negative comes out. That makes us have an I. So it's I times the square root of 9. Well, the square root of 9 is 3. So this is I times 3, which we just say is 3I. We'll put the 3 in front. So this is 3I, which is imaginary. Okay, let's do another one. I didn't do this one right here. The square root of negative 4. Same way, the negative comes out, which gives us an I times the square root of 4. The square root of 4 is 2, so this is I times 2, which is 2I. These are imaginary numbers. Okay. Well, what is complex? Complex is when you have an imaginary number with a real number, like this right here, 3 plus 2I. This is a complex number, because right here, this is a real number. This is real. And this right here, this is imaginary. So a complex number has a real part and an imaginary part. And that's what a complex number is. So we're going to look at complex numbers. We're going to look at how to add them and subtract them, multiply them, divide them. We're going to look at all this stuff, because complex numbers, they're not real because it's got this imaginary part, but they do have applications. One of the biggest applications is electrical devices. Electrical devices, circuitry, electricity, all this is generated by complex numbers. So it's pretty amazing. Anyway, let's look at some problems like we're going to have. And right here on this first one, the imaginary unit I is defined as I equals, this is the square root of negative 1. Now, I squared, all right, here you go. If I is the square root of negative 1, if I square that, well, the square and the square root will cancel each other, which is just negative 1. So I squared is negative 1. So this is something you got to remember there. I squared is negative 1. Write this in your notes or somewhere you won't ever forget this. I squared equals negative 1. This is important. Okay. All right, so it's got multiple choice here, but you can see I right here. There's the answers right there. I is square root of -1. I squared is -1. Okay, now right here, number 2, here's a complex number, 6 plus 5i. And there's another one, 6 minus 5i. All right, now these right here are what you call complex conjugates. Right here's my answer right there, complex conjugates. Because they have the same two numbers, the same real number, the same imaginary number, but one's plus and one's minus. Here's another couple examples. 2 plus 5i, 2 minus 5i. These are complex conjugates. 7 minus 6i, 7 plus 6i. These two are complex conjugates. Okay? All right, now let's look at this right here. What happens when you multiply some? Oops. What happens when you multiply some square roots? Well, right here, this is radical -19 times radical -19. Well, right here, this negative is going to come out, which makes us have an I times positive radical 19. Same thing here. This is going to send out an I times 19. Okay? So I got I times 19 times I times radical 19. Okay? Well, I times I can multiply those together, which would give me I squared. And then radical 19 times radical 19, well, that's just 19. And so I squared, and then like we just mentioned up here a minute ago, I squared is -1. Okay, so right here, this is -1 times 19, which is -19. So there's my answer right there. And you can see down here, -19 is what that was. All right, I think there's another one like that. No, maybe not. Let me make up one. Okay, what's a radical -22 times radical -22? Okay, so right here, this negative comes out, which makes us have an I times radical 22. Right here, this negative comes out to make an I times radical 22. Okay, and now I have I times radical 22 times I times radical 22. I'm multiplying all these, which means I can switch them up. I'll explain that a little bit better here in a second. So I can do I times I, which is I squared. And then I can do radical 22 times radical 22, which radical 22 times radical 22 is just 22. Well, then I squared, like we mentioned a while ago, that's -1 times 22. And then -1 times 22 is -22. And that's my answer. Now, what you could do, maybe to make this process a little simpler, radical -22 times radical -22. Okay, well, that's going to be radical -22 squared, because I'm multiplying it by itself. And so what I could do is the square and the radical cancel each other. So that's just -22. So it's a lot quicker doing it that way. What I started to say right here about this a minute ago, if I have multiplication like 2 times 5 times 2 times 6, maybe, I don't know. Okay. If I go straight across, 2 times 5 is 10, 10 times 2 would be 20, and then 20 times 6 would be 120. Okay? But now, in multiplication, the cool thing about multiplication is you don't have to go in that order. You can skip around. So I can do 2 times 2, which is 4, and I can do 5 times 6. I can do 2 times 2, which is 4. I can do 5 times 6, which is 30, and then 4 times 30 is still 120. So when you multiply numbers, when you have several things you're multiplying, you don't have to go in that specific order. You can jump and skip and do things like that, which might make it easier multiplying, depending on what the problem is. And that's what I'm doing up here on this. When I have I times radical 22 times I times radical 22, then I can multiply my i's together, which is I squared. I can multiply the radical 22's together, which is just a 22. So that's what I was doing there a minute ago. All right, so let's go to number 4 here. We're dividing this. Radical negative 405 times radical negative 81. Well, the negative comes out of this, which is I times radical 405. Okay, same thing in the bottom. The negative comes out as an I, and that's radical 81. Okay, well now when I'm dividing, these i's will cancel each other. So there is no I now, they divide it out. And then I've got this over this. Well now, what might make this easier is we can, since I got a radical over a radical, I can put it in one big radical, and I have 405 divided by 81. Okay, and then I get my calculator here, and I can just do 405 divided by 81 and just see what that comes out to be, which is 5. So this right here in the radical is 5. So that's radical 5, which I don't think I can do anything further than that right there, and that's really what the answer is, radical 5. Okay. Now look at this one right here, number 5. We got a couple like this together here. All right. Write this number in standard form. All right, so we got negative 10 plus radical negative 40. All right, right there, that negative radical 40, that negative will come out of the radical. So this is going to be negative 10 plus I radical 40 divided by 2. Okay. Now what we got to do here is this radical 40, it may simplify, and I think it does. Let me come over here. Got radical 40. Now this is how you simplify radicals, and I may have to do a few of these to get you squared away. Some teachers teach this differently. What I like to do is just break it down. I start with my 2's. 40 is divided by 2, so 40 divided by 2 would be 20. And I circle my 2 because it won't break down. I just start with my small numbers and keep going. 20 divided by 2 is 10. Circle my 2. 10 divided by 2 is 5. Circle my 2. 5, it won't break down, so I circle it. So there you go. There's 40 broke down into prime factorization. Now, when you look at these prime numbers, if you have a pair of anything, it will pull out of the radical. And right there's a pair right there. So I'm going to pull that pair out. So these two, they pair together and come out of the radical. This 2 does not have a partner to pair up with, so he's stuck in the radical. And this 5 as well, he don't have a partner to pair up with, so he's stuck in the radical. So this 2 comes out, and then this 2 and 5 are stuck. So I've got a 2 coming out. 2 times 5, I multiply those, that'd be 10. And that's 2 radical 10. So right here on this problem, I don't know if I left enough room here. This is negative 10 plus, and I got this I already out. So this is 2 radical 10. The I goes between the 2. And then I got this 2 on the bottom. So this right here is 2I radical 10. Okay. And now you're done with this unless these 3 numbers right here, unless they divide down, and they do, they all divide by 2. So negative 10 divided by 2, we'll do it right here, is negative 5. 2 divided by 2 would be 1, so it's just plus 1I radical 10, or just I radical 10. And on the bottom, 2 divided by 2 would be 1. And there you go. That's what it simplifies to. And now since that's a 1 down there, then we just don't even have to have it. And there's my answer right there, which you could see. That's what we got over here. Okay. Let me do a few more radicals. Let's just break some radicals down like radical 96. Okay? 96, well, I start with 2. 96 divided by 2 is 48, and I circle my 2. Now 48, I just stick with 2. 48 divided by 2 is 24. And I do 2's until I can't do it no more. 24 divided by 2 is 12. Circle the 2. 12 divided by 2 is 6. Circle my 2. 6 divided by 2 is 3. Circle my 2. 3 does not break down, so there you go. So there's all my prime factorizations of 96. Okay, we're right here. Here's a pair of 2's, so that's going to send out a 2. Here's another pair of 2's. That's going to send out another 2. This 2 right here does not have a partner, so he's stuck in the radical. And this 3 doesn't have a partner, so he's stuck in the radical. So I've got these 2 pairs coming out. So 2 times 2 would be 4 coming out. And then 2 times 3 is 6 stuck in the radical. And that's how I simplify radical. Okay. Let me see here. Making up one. 1458. Here's a big one. Okay. Well, let's just bring our calculator in here so you can see as I do it. I always start with 2 and then work my way up to 3's and 5's and whatever. But 2, I think, goes into that 1458 divided by 2. You just do this right here, and there you go. That's 729. Circle my 2. Okay, 729 divided by 2. All right, it doesn't do it no more. So that's the only 2 that goes into it. So now I'm going to go to 3 now. 729 divided by 3. All right, that's 3 times 243. Circle my 3. Now 243 divided by 3. All right, that's 81. That's 3 times 81. Okay, circle my 3. 81 divided by 3, that's 27. So it's 3 times 27. Circle my 3 because it won't break down. 27 is 3 times 9. And 9 is 3 times 3. There you go. There it is, all broke down. Now, what's my answer here? Well, this 2 right here does not have a partner, so he's stuck. All right, now right there, there's a pair of 3's. There's a pair of 3's. There's a pair of 3's. All right. This is going to send a 3 out of the radical. This is going to send a 3 out. This is going to send a 3 out. So I multiply those. 3 times 3 times 3. That's 27. And then I got this 1, 2 stuck. That's how you simplify radical. That's 27 radical 2. Okay. We'll do another one here, number 6. So I got negative 108. All right, I'm going to come over here and give myself a little more room. Negative 108. All right, that negative is going to send out an I. Okay. And I got 108. Now I'm going to break down 108, so I'm going to start with 2. So 108 is 2 times 54. Circle my 2. 54, well, that's 2 times 27. Circle my 2. 27, that's 3 times 9. 9 is 3 times 3. And there you go. There it is, all broke down. Okay, now my 2. Oh, there you go. There's a pair of 2's, so that's going to send a 2 out. 3, there's a pair of 3's. That's going to send a 3 out. This 3 is stuck because he doesn't have a partner to pair up with. So he stays in the radical. So 2 times 3 is 6 coming out. Okay, get it up here where you can see it. And then this 3 right here is stuck. So that's going to be 6 radical 3, and my I goes between them. So that's 6I radical 3. Okay, so up here, this is 4 minus 6I radical 3, all divided by this 2 down here. Okay, and I'm done unless these 3 numbers right here divide down. Well, they do. They all divide by 2. So 4 divided by 2 is 2. Minus 6 divided by 2 would be 3. 3I radical 3. And then 2 divided by 2 would be 1. And then since this is a 1 down here, I don't have to have it. And there's my answer right there. And I think that's what we got. Okay. All right, now we're going to do some adding, subtracting, and some things. So like right here, and this should be pretty easy. This is just like something you may have done before. We're going to add these two complex numbers. All right, so I add the real parts together, and I add the imaginary parts together. So my real part here is 4. My real part there is 2. So 4 plus 2 would be 6. And then I add the imaginary parts. Positive 6i plus a negative 5i. That would just be a positive 1i. So that's 6 plus 1i. There you go. That's my answer. Okay. On this one here, we've got several things here. We're subtracting, actually. Look, for subtracting this one, subtracting that one. Now, here's where you get into trouble when you subtract. Okay? Let me show you something about subtraction real quick. When you have subtraction, like 4 minus 2. 4 minus 2 is 2. Okay? But what you can do is you can change that. You can change this right here to a plus. And then change this 2 to a negative 2. You can do that as well. So 4 plus negative 2. 4 plus negative 2 is 2. So any subtraction you have, you can change it to an addition problem if you change the number after to the opposite. So 4 minus 2 is the same thing as 4 plus negative 2. We change this to plus and change this to the opposite. Now, why would we do that? Well, in this case, it'd be kind of dumb doing it here. But when you have something like this right here, it helps us to get the thing correct. Because see, when I'm subtracting here, I'm not just subtracting 4, I'm subtracting 4 plus 4i. And I can make mistakes there. So what I'm going to do is, let's do right here. I've got 3 minus 4i. All right, now right here, I'm going to change this subtract to an add. Okay, and then right here where I have 4 plus 4i, I'm going to change these to opposites. So this 4 right here becomes a negative 4, and this plus 4i becomes a minus 4i. And then right here again, I got another subtract. So I'm going to change it to add. And then stuff after it, I'm going to change them to opposites. So like right here, see this negative 5? Well, that becomes a positive 5. And then my plus I would be a minus I. And there you go. This is much better than that. This is going to cause you to make mistakes here. So you change the minuses to pluses and then change these to opposites after it. Change this minus to plus and then change these to the opposites after it. And now you can just add. So I just go through and add now. 3, do my real parts first. 3 plus negative 4 is negative 1. And negative 1 plus 5 would be positive 4. It's going to be a positive 4 for the real part. Now the imaginary part, I've got a negative 4i plus a negative 4i, which is negative 8i, plus a negative I. So negative 8 plus negative 1 would be negative 9, negative 9i. And that should be my answer right there. And you can see it. That's what it was. Find the sum or difference here. These have radicals in them. Okay, same thing. I'm going to do the same thing here because see, this is minus in this one, minus in that one. So I'm going to do the same thing I just did in that problem. So I've got this negative I radical 5 minus 2. Okay, we're just going to leave that. But now right here, this minus, we're going to change it to plus and then change this to opposites. So the 6 becomes a negative 6. And the minus 7i radical 5 becomes a plus 7i radical 5. Okay. I'm going to have to move this over just a little bit. And then right here where I got minus all this, I'm going to change it to plus. And then my 2 becomes a negative 2. And my minus I radical 5 becomes a plus I radical 5. Okay, there we go. This is much better than that. This is going to cause us to make mistakes. So I changed the minuses to pluses. And then what's after the minus, I change those to opposites. There's a minus, change it to plus, and what's after it, I change it to opposites. And now I can add. So let's add the whole number stuff first. Like right here, I got a -2 plus a -6, that's -8, plus a -2, that's a -10. Okay? And then I'm going to add the radical stuff. So here's a radical, here's a radical, here's a radical. They're all the same radical. So I can put those together. I can put them together if they're the same. If this was a 7 in here, I couldn't put it together. All right, so I got -1i plus 7i. Well, that would be -1 plus 7 would be 6. 6i, radical 5. And then plus 1 more I, radical 5. So that'd be 6 plus 1 would be 7. Plus 7i, radical 5. That should be my answer right there. And looks like it is. -10 plus 7i, radical 5. All right, so that's a little bit how you add them. Now we're going to get into multiplying. And here's where it gets a little bit different. It's not really complicated, but when you multiply two complex numbers like we are here, okay, you can see my answer down here, okay, I've got to do -3 times all this, and I got to do 6i times all this. So I think the most successful thing I've done with this is doing a multiplication box. Okay, I'm going to make a multiplication box. And this first one, -3 plus 6i, that goes on top of the box. And I put the real part here, and I put the imaginary part here, and I got a column for the real part and a column for the imaginary part. And then this second one, -3 plus 7i, I put it on the side. And now I'm going to multiply. And each of these squares here, there's 4 of them, is a product. This organizes the problem for multiplication, organizes it for you, and it makes it a little bit more of a routine. It's like right here in this box, that's going to be -3 times -3, which is 9. Okay, right here in this box, this is -3 times 6i. Well, -3 times 6 is -18. And I got my I there, so -18i. Right down here, -3 times 7i is what this is. -3 times 7i, well, that's -21i. Okay. Now, this last one here, I always do it outside the box because I'm going to have an I squared here. And I squared is -1. But look what I do here. In this box right here, I'm going to have 7i times 6i. Well, 7 times 6 is 42. But I've got 2 i's here, which is I squared. Okay, now as we just talked a while ago, I squared is -1. So 42 times -1 is -42. And that's what's in this box here. Okay, so every time you do multiplication, this square down here always turns into a real number. And so these two are real numbers, so I add them together. So I've got 9 plus -42. Now, that's a negative there. 9 plus -42 is -33. And then the squares going this way are always going to be imaginary numbers. So I've got -18i plus -21i, which is -39i. And that's my answer right there. And you see that's what we got. Okay. All right, here's another one. Now, this right here, if you remember from just a few minutes ago, these are complex conjugates. Okay, complex conjugates have a special thing that happens when you multiply them. Let's do this box over here. Okay. All right. On the top, I got 8 plus I. And on the side, I got 8 minus I. All right, look what happens when we multiply these conjugates. 8 times 8 right there is 64. In this square, 8 times I, that's 8i. Down here, 8 times -i is -8i. And then in this square, I always do it outside. This is -i times +i. Well, that's like -1 times +1, which is -1. And then I times I. is I squared. Okay? So negative 1 times 1 is negative 1. I times I is I squared. All right, well, I squared is negative 1. So I've got negative 1 times negative 1, which is 1. So this is a 1. Okay? And now if I add the real parts together, 64 plus 1 is 65. If I add the imaginary parts, and here's what always happens. This is positive 8i, that's negative 8i. They cancel. So the answer is just 65, as you can see right here. And that's what will always happen when you multiply conjugates. You'll always have just a real number, and you will not have any imaginary part. Here's another one right here. See, these are complex conjugates. So I got negative 1, I got minus 4i, I got plus 4i. These are complex conjugates. So when I multiply them, negative 1 minus 4i, negative 1 plus 4i. Okay, so right here, negative 1 times negative 1 is 1. Negative 1 times 4i is 4i. Negative 1 times positive 4i is negative 4i. And see, they were going to cancel. And then in this square right here, I've got positive 4i and negative 4i. Well, positive 4 times negative 4 is negative 16. I times I is I squared. Okay. Well, negative 16 times I squared is negative 1. So that's a positive 16. So in this square, I got a 16 positive. So 1 plus 16 is 17. There you go. There's my answer. Okay. Now, what about this? 3i times 5 minus I squared. Okay. Well, I got 5 minus I squared. Probably ought to go ahead and just square that. So let's just build a box. I got 5 minus I times 5 minus I. When I square it, it means I'm multiplying it times itself. So 5 times 5 is 25. 5 times negative I is negative 5i. 5 times negative I is negative 5i. Now these don't cancel here. See, that's negative 5 and negative 5. So that's not going to cancel like the previous ones did. In this last square, I got negative I times negative I. Well, negative 1 times negative 1 is 1. And then I times I is I squared. And I squared is negative 1, so this is 1 times negative 1, which is negative 1. This is a square right here that people mess up on. You have to be, that's why I do it outside here. I just go down through it like this right here to get that square right. And now 25 plus negative 1 would be 24. Let me write right here, 3i. I got the 3i here. And this is going to be 24 plus, and then negative 5i plus negative 5i is negative 10i. But I should put just minus 10i. Okay. So 25 plus 1 is 24. Negative 5i plus negative 5i is negative 10i. And now I've got this 3i times that. So now all I do is I just distribute. So 3i times 24, all right, 3 times 24 is 72, so it's going to be 72i. And now if I distribute over here, 3i times negative 10i. All right, so 3 times negative 10 is negative 30. And I got I times I, which is I squared. Okay, well right there, I squared is negative 1. So this is negative 30 times negative 1, which is a positive 30. So I got 72i plus 30, or usually now when we have imaginary numbers, complex numbers, the real part goes first. So I'm just going to switch it. I'm going to put the positive 30 in the front, which you can see right here, and I'm going to put the 72 in the back. So plus 72i. The real part, we always have it first. Okay. All right, what about 14 here? We got 3 things we're multiplying. All right, so well, look here. The first 2, look here. These first 2 are complex conjugates. So I've got this. Let's do those first. 3 plus I, 3 minus I. Okay, right here, 3 times 3 is 9. Right here in this one, 3 times I is 3i. Down here in this one, 3 times negative I is negative 3i. And see, they're going to cancel. Complex conjugates. And in this last one, negative I times positive I. Well, negative 1 times positive 1 is negative 1. And I got I times I, which is I squared. Well, I squared is negative 1. So negative 1 times negative 1 is 1. So that's a 1 in that square. And so 9 plus 1 would be 10. And that cancels. All right, so when I do these first two right here, okay, these first two, that's going to give me a 10 times 6 plus 4i. Okay, so we got 10 times 6 plus 4i. All right, so I just distribute that. So 10 times 6 is 60. 10 times 4i is 40i. And there you go. That's the answer. All right. Okay. Now, that leads us to division now. We got some division problems. Okay. Divide these right here. Well, when you divide, let me get a paper here. When you do division, 7 plus I divided by 7 minus I. All right, on division like this right here. You can't really divide. So what you're going to have to do is you look at the denominator here and you get the complex conjugate and you multiply the top and bottom by that complex conjugate. So what I'm going to do is my complex conjugate of this is 7 plus I, which just happens to be what's in the top. And I'm going to multiply top and bottom by that. Okay, which means I have these on the bottom to multiply and I have those on the top to multiply. So I have two boxes I'm going to have to do. So, all right, this box here, this is my top. Okay, I've got 7 plus I, and I got 7 plus I. Okay, this is the top. Well, 7 times 7 is 49. 7 times I would be 7i. 7 times I is 7i. And then right here in this one, I times I is I squared, which is negative 1. So that's a negative 1. So I got 49 times negative 1, which is negative 49. And right here, 7i times 7i is 14i. And there you go. There's my top. Okay. Now I got my bottom. All right, on the bottom, that's the ugliest box I've ever made in my life. All right, in the bottom, I got 7 minus I, and I got 7 plus I. All right, these are conjugates, so the imaginary part should delete out. 7 times 7 is 49. 7 times negative I is negative 7i. 7 times I is positive 7i, and yes, they cancel out. Then I have I times negative I, which 1 times negative 1 is negative 1, and then I times I is I squared. And I squared is negative 1, and that makes us have a positive 1. Negative 1 times negative 1 is positive 1. So this is a positive 1 right here. And then 49 plus 1 would be 50. Okay? Now, when I have a complex number here divided by this, I got to split it up. So I split it up like this right here. I got negative 49 over 50. And I got a plus. And I got 14i over 50. Okay. And then I try to simplify those if I can. This right here does not simplify. Now this does because 2 goes in both of those. So 2 goes into 14 7 times. 2 goes into 50 25 times. And then I got my I on the side. And that should be my answer right there. Let's look and see if we got this right. Oh man, we made a mistake here. That should have been 24 over 25. What do we do here? We made a mistake. I make mistakes too sometimes. Oh. right here. Yep, right here. I didn't add them together. 49 plus -1 is 48. So this should have been 48. I multiplied them. That's what I did. I got in a hurry. That should have been 48. So this should have been 48 right there. All right, so that's going to be 24 over 25. There you go. That's right. When I add them together, I accidentally multiplied. So I don't know why I did that. It's early. Here's another one. See if we can't do this one right. Okay. All right, so I've got on this problem here, 1 plus 3i over 1 plus I. All right, we're going to do this division, which means I need to do the complex conjugate top and bottom. So 1 plus I, that'd be 1 minus I, top and bottom. Whatever your bottom is, you complex conjugate it, top and bottom. Which means I have 2 multiplies. So I got 1 plus 3i, 1 minus I. I'm going to multiply the tops. 1 plus 3i, 1 minus I. 1 times 1 is 1, 1 times 3i is 3i, 1 times negative I is negative I, negative 1i. And now in this one here, negative 1 times 3 is negative 3, and I got I squared. Okay, I squared is negative 1, so that's going to be a positive 3. Okay, oh man, it wasn't on the screen, I didn't realize it. So there's what I get when I multiply them. Do this again here on this last square. Negative 1 times 3 is negative 3, I times I is I squared, which is negative 1, and that's a 3. So 1 plus 3 would be 4. All right, so this is going to be a 4. And then right here, when I do the imaginary part, 3i plus negative 1i would be a 2i. And there's my top. All right, what about the bottom? Well, these are complex conjugates. So let's do this square right here. I got 1 plus I, 1 minus I. 1 times 1 is 1, 1 times I is I, 1 times negative I is negative I. Look, they cancel. And then negative I times positive I. Well, negative 1 times 1 is negative 1. See, negative 1 times positive 1 is 1. And then I times I is I squared. Well, I squared is a negative 1, which gives me a 1 there. Okay, and then 1 plus 1 would be a 2. Okay, and now, all right, this is cool because 2 divides both of those. I got to split them up. So 4 over 2 would be 4 over 2, and then 2i over 2, and then 4 over 2 is 2, and then 2 over 2 would be 1, so it would just be 1i, and that should be 2 plus I. Okay. And that's what the answer was over here, so we're in good shape. All right. Now, here's an application where complex numbers can be used right here. Complex numbers are used to describe current, voltage, and impedance. This is in electricity, electrical circuitry. These 3 quantities are related by this equation, E equals IZ. E equals IZ. E right here is your voltage. I right here is your impedance. I'm sorry, that's your current. Z is your impedance. I don't know why they use I for current instead of impedance, but that's what they do. All right, so we have I is this, we have Z is this. So in this problem right here, I is 6 plus 6i. Z is 8 plus 3i. What is my voltage? What is E going to be here? So I just multiply those together. So let's do that real quick. 6 plus 6i times 8 plus 3i. So I'm going to do a box. Okay. 6 plus 6i, 8 plus 3i. All right, 6 times 8 is 48. 6i times 8 is 48i. That's a 48 right there. Okay, kind of hurry. 6 times 3i is 18i. And then 6i times 3i. All right, 6 times 3 is 18. I times I is I squared. All right, I squared is negative 1. So 18 times negative 1 is negative 18. There you go. That's what goes in there. So 48 plus negative 18 is 30. And then 48i plus 18i would be, was it 66? And there you go. And I think it's what we had right here. It's 30 plus 66i. Pretty good shape. Here's another one. Okay. E equals IZ. All right, I in this problem is 6 plus 5i. And then it says E over here is 2 plus 8i. And I'm looking for Z this time, which means I'm going to have to divide both sides by 6 plus 5i to make this cancel. And Z is going to be this divided by that. So that's what we're doing here. We're going to do the E number divided by the I number. So let's see here. I'm going to do 2 plus 8i divided by 6 plus 5i. So we're going to do this division. And this will tell us what the impedance is. So I'm going to multiply top and bottom by 6 minus 5i. Okay. All right, so we're going to do the tops then. Here's my top box. I got 2 plus 8i. I've got 6 minus 5i. 6 times 2 is 12. 6 times 8 is 48i. Negative 5 times 2 is negative 10i. And then right here in this last one, negative 5 times 8 is negative 40. And I got I times I, which is I squared. All right. I squared is negative 1. And then negative 40 times negative 1 is 40. So that's a 40 right there. So I got 12 plus 40, which is 52. And then 48 plus negative 10 would be a positive 38i. So there's my top. Okay. Now what about the bottom here? All right, so I got these are complex conjugates. So 6 plus 5i, 6 minus 5i. 6 times 6 is 36. 6 times 5i is 30i. 6 times negative 5 would be negative 30i. And then right here in this last one, negative 5 times 5 is negative 25. I squared. All right, well, I squared is negative 1. So that's going to be a 25. Okay. And now, let's see here. See, these cancel. Then 36 plus 25 would be 61. And then, there you go. I split these up. So this is going to be 52 over 61 plus 38 over 61i. And then I simplify them. I don't think it does. You can see my answer over here. It's not going to simplify any. There's my answer. Okay. Now, we've got a few of these. I to the 26th power. What would that be? All right, well, here's what happens. I to the 1 power is I. I squared, we just talked about that a whole bunch here today. That's negative 1. I to the 3rd. All right, I to the 3rd is going to be I times I squared. So I squared is negative 1. So it's going to be I times negative 1, which is negative I. I to the 4th power. Okay, I to the 4th power. Now that could be I squared times I squared, which is negative 1 times negative 1, which is 1. Okay. So this is 1. And then I to the 5th power, well, that just starts the whole routine over. So we just have these 4 things that just keep repeating over and over and over. So these 4 here are the main ones. Okay, so what you do when you have one that has a high power, like 26, I to the 26, all you do is you take 26 and you divide it by 4. All right, so I take 26, divide by 4. Okay, we get on here, we can see it. 6.5. All right, so I get 6.5, which is 0.50. Okay, now I ask myself 0.50, how many quarters, if we're looking at money, how many quarters would 50 cents be? Well, that's 2 quarters. So that means I to the 26 is the same thing as I to the second power, because that's 2 quarters. And then I squared right here is -1. Okay, what about this one down here? It says I, get it scrolled up here a little bit better. I to the 11 power. All right, so I take 11 and I divide it by 4. All right, when I punch that in, 11 divided by 4 is 2.75. Okay? So I asked myself, 0.75, how many quarters is that? Well, that's 3 quarters. So that means I to the 11 is the same thing as I to the 3, which is -I. Okay? What about this one here, I to the 64? Well, I do 64 divided by 4. Okay? When I do that, that comes out to be 16, which has no quarters, which means we've actually had 4 quarters that made a whole dollar now. So that's 4 quarters, which is just 1. Okay? So this is 4 quarters, which is I to the 4th. So this is actually I to the 4th, which is 1, because we had no quarters, which is actually 4 quarters. Okay? Now, what do we have here on this one? 1 over I to the -26. All right, when I have a fraction and I got a negative exponent, this can go up, which would be I to the 26 over 1. So when a negative exponent can push to the top, same thing if it's in the top, it could push to the bottom. And so this is going to be I to the 26. And so I do 26 divided by 4, which is going to be 6.5, 6.50. How many quarters is that? That's 2. So it's the same thing as I squared, which is -1. All right, now, number 23 here is -12 plus I a solution to this equation. Okay, before we do that one, let's go down to here, because this is the same thing. It says, how can it be shown that -3 plus 4i is a solution to this one? Okay, what you do here, -3 plus 4i, I'm going to put that in for x. So I'm going to have -3 plus 4i squared plus 6 times -3 plus 4i plus 25. I'm going to put this in where x is. All right, so basically, let's see here. Which one of these is right here? This is D. I could have just looked at the answer down here. Anyway, see, I'm putting -3 plus 4i in for x right there squared, plus 6, and then I'm putting -3 plus 4i in for x here, plus 25, and that should equal 0. Okay? Now, that's what I'm going to do here. I'm going to put -12 plus I in for x here, so I'm going to have -12 plus I squared plus 24 times -12 plus I plus 145, and that should equal 0. Okay, so right here I'm going to have to do -12 plus I square that. All right, let me get another piece of paper here. -12 plus I, -12 plus I. All right, -12 times -12 is 144. This is -12i. This is -12i. And this is going to be I times I, which is I squared, which is a -1. Okay? All right, so that's going to be 144 plus -1 is 143. And then that's minus 24i. All right, that's what I get when I square that. Okay, now right here I distribute. So 24 times negative 12, that's going to be 288, negative 288. And then 24 times I is 24I plus 145. Does that equal 0? I'm going to put a little question mark there because we're not sure if it does or not. But when I add, all right, so I do my real parts. These are my real ones. All right, just use my calculator here. Okay, so I have 143 plus negative 288 plus 145, and that comes out to 0. That's my real part. Now my imaginary part right here, negative 24i plus positive 24i, well those cancel. So that's 0. Yeah, this is 0. So yeah, that's right. This is a solution, and the answer was yes. Okay. All right, we're about to finish up here. Here's one where we're dividing this, and the answer comes out to be this right here. I'll let you pause this, and you can try doing this yourself. And then here's another one here, I to the 13. You can pause this, and there's what your answer should be there. You try those on your own. All right, so hopefully this all makes sense. Complex numbers. If you have any questions, just shoot one at me, and we'll try our best. Have a great day.